gonna tell you some things about linguistics and computational linguistics. First, a disclaimer. It's not gonna be about this. Like at all. Like you will be, I can't figure out what's happening with it. You will be surprised to what degree it is not about large language models. What should we do with the sound? Should we make it quieter or is it good? Because I'm worried about that. Okay. All right. I will mention large language models once maybe during this, and it's not going to be a direct relationship to what I'm talking about. However, I am familiar with them, and if you want to ask me something about them at the end, I will not hold it against you. Okay? I will not be offended, even if it's not related to my topic. All right. So I'm a linguist, and I will tell you a few things about what that means in a moment. I'm very much not a Python expert. Most of you here probably, should I just get rid of this?
No.
No?
You are just adjusting. Don't fear anything.
Because I don't want this to be annoying.
No.
Either.
Go ahead, no problem.
Yeah, I'm not a Python expert, and most of you here probably know a lot more about Python than I do. Furthermore, if you saw how I write Python code, you would probably kick me out and ban me from this class. I will show you some Python things. Don't worry. There will be some Python shown on the screen, so hopefully you will not be entirely disappointed. It is important to note that Python indeed is the lingua franca in academia today. So not only in many industry situations, but in academia for sure, everybody today is using Python, which is very important because one thing that it helps us do is bring different fields together. So this way someone who is working in linguistics can collaborate with someone who works in, I don't know, philology or anthropology or some other field where they also process data using Python. In particular, I work with something that is called syntactic theory. What is syntax? If any of you have worked with compilers or have written a compiler or have edited a compiler, you know very well what syntax is. So here on the, let me try this, on the left part of the picture, you see something from the compiler world. It's the syntax that could be used to interpret statements in a programming language. On the right, you see something that is more related to human languages. But you can see immediately that it's very similar. We have some kind of structure which we visualize as a tree, and the structure we need for some reason. Now, which reasons, what reasons do we need them for? Basically, syntax is a theory behind the structure of a phrase, be it a phrase in a programming language or a human language. And we need that structure in particular, so we need it for two things. One thing is basically to know what is possible in a certain language and what is not possible. So for example, in Python, what is it that you can write and what is it that you cannot write, in the sense that if you will write it, then the interpreter will not know what to do with it and will break and give you an error, etc. It's very similar in human languages. As linguists, we're very interested in this same question. What is it that's possible in human languages, and what is it that's not possible? So in this sense, it's the same thing. The second thing that we need the structure for is to help us interpret a statement. So suppose a statement is possible, but what does it mean? What should the interpreter or the compiler do with that statement? How should it interpret it? And in human language syntax, it's very similar. As linguists, we also want to know the structure of a sentence in order to understand how does it come together as an interpretable, semantically valid sentence? So how does the structure of the sentence relate to what it means, helps construct the meaning? There is, of course, a huge difference between human languages and computer languages. There are many differences. You could probably think of quite a few. I don't know, does anybody want to suggest some of the differences? Like what is it that could be different between English or Spanish and Python in terms of, let's think in terms of structure, okay? Any ideas?
So sometimes you have the possibility to say something in different ways.
Exactly.
There are synonyms and...
Precisely, that's precisely what I have in mind. You could come up with other ideas too, but one main thing that is characteristic of human languages that is absolutely impossible in programming languages is ambiguity. In programming languages, we want to avoid ambiguity at all possible costs. We cannot have the compiler wonder what it should do. In human languages, it's completely different. We, in fact, there are situations where we want to avoid ambiguity as well, but in principle, we as humans evolved to want to have it. We want to have ambiguity in language because that's how our social interaction is constructed. So I will talk more about ambiguity, but first let me just show you a couple of different ways to represent syntactic and semantic structure. So here on the left you have a visualization of syntactic structure, and on the right you have the sort of semantic structure corresponding to it. And what I want to, so the reason for these pictures is just to introduce the concept of both types of graphs. So on the left you see the so-called constituency structure, and on the right you see the so-called dependency structure. And if you've ever worked with any kind of text processing, you may be familiar with the dependency structure. You may have seen it. In particular, this picture comes from the Universal Dependencies Project website, which you can check out, and that's like a collection of sentences annotated with this kind of structure. How is one related to the other? I'm not going to explain exactly how you can derive one from the other, although you can, or you should be able to if you have the right understanding of the structure of the phrase, then one should be directly derivable from the other. But the point is, if you can derive one from the other, then you have your goal. You know at this point how the semantics comes together from the syntax. How did syntax help you construct the semantics? And the semantics in this sense, in this very, very simplified sense, is basically who did what to whom, why, and where. So that's when we communicate, that's what we want to know immediately. And this kind of semantics is directly related to syntax. There are other types of semantics which are not, but we're not talking about them today. Now, one thing that I will come back to about the Universal Dependencies project, where this picture comes from, is that those collection of sentences were annotated by hand, by people. So they decided on a certain labeling scheme, so they had some ideas about how these sentences should be annotated, and then they came together, lots of people, and they spent some very significant time annotating sentences by hand, like this, which, as you can imagine, can be very inconsistent, prone to error, and in fact the same person is very likely to annotate the same sentence differently if they encounter it 20 days after they encountered it for the first time. So our goal as computational linguists is to come up with a way to do that automatically, which is to say we want to have a grammar of a language. We want to have a grammar for any language for which we want this kind of result, for which we want to have a system which can annotate sentences in this way. Now let's go back to ambiguity for a second. So this is just an example to illustrate ambiguity and how a sentence can have at least a couple of different valid meanings. So Arthur does not study because Python is easy. Does Arthur study? Sure?
There are two, both senses.
yeah, there are two senses, at least two valid senses to this sentence. One is that Arthur does not study, and that so there is no studying taking place. There's no event of studying, and that is happening because he considers the subject to be too easy. So he thinks he's going to pass the exam anyway, even if he doesn't study. All right, and this is reflected in this somewhat complex graph. But what matters here is that the main thing in this graph is the because relation. Okay, so something is happening because of something. X is happening because of Y. In this case, the studying, which happens to be negated, so the not studying, is happening because something is easy. The second possible interpretation is that it is not the case that the studying is not taking place, that the studying is taking place because Python is easy. And that is a less likely interpretation. It's less likely that somebody would say it with this intended meaning. But I'd argue that it's entirely possible. You know, like I'm studying not because I consider this easy and I prefer easy subjects. No, I'm studying because I need this particular subject for this particular person, and I don't care whether it's easy or not. So that's just an example of how something relatively subtle can be reflected in the structure. Now, this is basically one of the main motivations for even studying the structure, for even assuming the structure in human language. Because if it's just a string, if it's a sequence of words, then how is it ambiguous? How could it be ambiguous if there is nothing beneath it, right? The fact that we know it's ambiguous, the fact that it's ambiguous indicates that there is something underneath that sequence of words. And this is just our hypothesis of what that structure might look like. All right, so to summarize this intro part of the talk, we as linguists study syntax in order to learn more about the fundamental laws of human languages. We do that mainly just because we want to know. We don't do it necessarily for any other reason, but all right, if that's not sufficient for funding agencies, we tell them that we do that in order to be able to solve problems in industry and in the society, problems related to language in a generalized way. And I mean, of course it's very important. Of course I would like problems to be solved in a generalized way. Imagine writing a compiler if you don't know the complete syntax of the language for which you're writing a compiler. That would not be fun. So it's kind of what we are facing with language-related problems. We don't know the complete fundamental laws behind the syntax of human language, and that makes it quite difficult to solve problems related to language because we resort to solving them in an ad hoc manner. So that's the motivation behind the field of study. But you might ask me, but hey, when I was in school, our teacher was telling us, well, this is possible in Spanish, you can say this in Spanish, and this you absolutely cannot say, this is how Spanish works. So surely teachers have long figured it out, so don't we know the laws of syntax already? And no, we don't. What teachers have been telling you in school is what we refer to as the prescriptive grammar. They have not been telling you about what's possible and what's not possible. They have been telling you about what is prestigious and what is not. Because the teacher's objective, which is a very noble objective, is for you to enter the university and get a better job in the future. Very noble objective, but not a linguistic objective. Has nothing to do with the systematicity of language. So that's the difference. And when I use the word grammar, I do not mean the grammar that we learn in school. Okay, so teachers in all countries do this, and I'm not saying they shouldn't, but that's just a different universe. That's a different use of the terminology. Their grammar is not our grammar. In this picture, that's a meme where the heroine of the movie Arrival, instead of whatever she was showing, I don't remember what was it that she was actually showing in the movie to the aliens, is showing an illustration from a very famous classic linguistic experiment where the linguist performed an experiment where she showed that children who were, I think, just 1 year old, I think they were very, very young, 1 or 2 years old, she was showing to them something like this, some creatures, which were imaginary creatures, and she was telling them first, showing them one of them and saying, here's a wug. And there was no word bug. Nobody, it kind of sounds like bug, but this doesn't look like a bug anyway, so here's a wug. And then she was showing them 2 of them and saying, here's 2. And the children would say, oh, 2 wugs. And they were not saying wuggies or wucks or any other form of the plural that exists in the English language. They knew that the plural must be wugs. Even though, so that's something when you start learning how to write, the teacher is going to teach you, okay, you must write it with this letter, or you must insert an E, or whatever. But these children did not undergo any kind of language instruction whatsoever. They were 1 year old, and yet they already knew the laws of the morphology, right? So that was the first experiment that showed very convincingly that the fundamental laws of language are acquired in this kind of innate way, which does not require any kind of school instruction. All right, so my goal so far was to convince you that you might want to come up with a grammar of a language, whichever language, right? Each language is going to have its own grammar. There's going to be fundamental similarities, but there are going to be differences. How do I do that? How do I build such a grammar? Remember, we wanted to be computational. We wanted to be basically a program, a machine executable program, rather than something that we would have to do by hand. So overwhelmingly, not only in computational linguistics, but in many other fields, there are 2 broad types of methodologies, formal and statistical. All right? Formal is something that you as a person create by hand. So you write a compiler by hand, you write a grammar by hand. You come up with a set of ideas about how the language works, you implement that set of ideas, then you deploy that on some data, you observe the result. That's the formal methodology. The statistical methodology, which is the basis of all machine learning and deep learning and so on, is a different philosophy which says, let's take a large amount of data and let's infer, for example, the grammar or whatever it is that you want, let's infer that from this raw data. Now, when earlier I pretended I'm asking myself the question, but haven't teachers already figured out the grammar, my answer was a resounding no. Like, I'm very sure teachers haven't yet figured out the grammar. But surely large language models have figured out the grammar by now. To this, I don't have a resounding no answer. What I'm going to tell you is that this is a very, very ancient debate, which is why I chose this painting where Plato and Aristotle are walking in School of Athens, and Aristotle points towards the ground, which is to say it's the matter that's important. It's the materialist point of view. The matter, in this case, we can translate into data. Suppose language is. It's the matter that's important. From the matter, ideas can be inferred. Ideas can rise. Plato is pointing up and saying it's the idea that is important, that comes from God. In the case of Plato, in our case, we will say it comes from the human itself, right? From human genius, which may or may not come from God, depending on your views. It's a very ancient debate, which I don't think has any definite answer. I think this debate needs to continue. These 2 methodologies need to continue coexisting, and they are both contributing to the scientific discourse over centuries. In my field, we use formal methods, at least for now. I personally don't think it's going to change because I don't see how it would make sense to try and infer something from the data which we don't yet know how we want to interpret that, right? Because even if you look at the data, you still need to interpret it in some way. And so for now, we're continuing coming up with ideas. Then once we have very good ideas about how the grammar should look like, maybe we will be able to learn something from the data because we already know roughly what we want to learn. All right, now it's time more or less for a demo. Don't get too excited, I'm not going to show you anything super beautiful. Syntactic structures aren't beautiful even when you visualize them as trees. They certainly aren't beautiful as Python objects. I'm going to show you something called the PyDelphin library. Now, Delphin is the name of an international research consortium which builds grammars. It builds grammars for quite a few languages. The largest ones, I think, are for these 4 languages, but there are others. So with these grammars, you can deploy the grammars on data, and the grammars will annotate the sentences for you with this kind of syntactic and semantic structures like I showed to you before. In fact, the Arthur doesn't study Python or whatever, the graph that I was showing you was produced by the English resource Grammar. What else did I want to say here? Yeah, so apart from grammars, we need parsers and generators and other tools, so that is also provided by the consortium. Now, before Python became the lingua franca, it was quite tricky to collaborate even within this consortium, let alone outside the consortium, because it was a collection of tools, well, it still is a collection of tools written in a variety of languages. It was very hard, it was like a very high entry bar. Now with Python, which came to the rescue, we have a lovely library which provides a lot of convenient functions and wrappers, and any student can just sort of can download a parser, download a grammar, and start working with it right away. It's much, much simpler, much, much better with Python. And like I said, Python tends to speed up research in many fields, not just mine. All right, so these are just some facts about the library, which I'm not going to read out loud. There is a developer guide. If one of you one day wants to contribute to the library, you're welcome to do so. And before I start with the demo, I will just conclude with, hold on. Yeah, I will just make sure I have shown you this. It doesn't matter, but I have to say it. It's a particular theory of syntax that we're using, which was proposed this year by these people. So just giving credit where credit is due. Let me just show you. Okay, now I need to be careful to not block I'm blocking the view. Yeah. How do we do this? How do we do it so I don't?
¿Podéis verlo o no podéis verlo? Sí.
Usually,
Yeah.
look at the screen.
No problem.
Okay. All right. So let's see. Let's start with this actually. Here's just something that exists on the web. It's pretty old though. There are much newer versions of this grammar, but unfortunately nobody uploaded them here to this demo website. Let's do that don't study example, and let's see how many senses it actually has, this sentence, according to the grammar. I don't study because Python is easy. And I'm not connected to the internet, so I'm not going to show you that. All right, that's fine. My guess is that it would have at least 10, maybe 20 different senses. Some of which would be extremely weird, but you can come up with a universe in which it would make sense. That's fine. Let's just do the.
Do you need the wipe?
We can provide you.
It doesn't matter. I
Okay.
wasn't going to do much of that.
You will be providing.
No, it's fine.
Oh, mama.
Oh, yeah. Doesn't make much sense, does it? Let's see. point here is the minimal toolkit to experiment is the parser and the grammar. The grammar you can download, the parser you can download. Once you have that, you can work with the grammar, and this already includes some Python stuff, even though the parser itself is not a Python program. But without this PyDelphin library, the result would be much harder to look at. Now, it's still not very easy to look at, especially not in this resolution. All right, what can I do about that? What can I do about this?
Wow.
All right. Anyhow, you can see. So what you see here is the same graph that we saw before. It's just that it's not visualized as a graph, right? Which is kind of the point, because the visualization is what I care about the least. That's not something I usually need. What I need is exactly all this stuff in text form, or better yet, of course not in the text form, but in the form of a Python object that I can manipulate, and that's exactly what the library provides to me. So after just showing to you that in principle there is command line interface, which you can use if you want, I'm going to switch to a PyCharm. So here I just wrote a little bit of code, not much, simply to demonstrate some of the things that the library allows me to do. So the library is installable via pip as usual, so you just do pip install PyDelphin, and then after that you can import the modules that you happen to want. In this case, I want the parser, for which the name is ACE. Now, all these idiosyncratic names you'd have to learn from the documentation if you were interested in this type of work. So you have to know that the parser's name is ACE. This is the dependency structure. This is a completely idiosyncratic name for the database style in which the results are stored. The results are very complex, so it makes sense to store them in a relational database. And for related reasons, we need the T-SQL module from the library. All right, so here I am giving it the path to the grammar, which I had already downloaded, and just some example sentence. So I'm gonna run the program, and let's see. What I want is a bigger. I'm not even sure I can make
I'm not sure if you can do some.
If I can make it
no,
bigger,
modify it in some way there.
I think I have done it before, but
maybe if you increase the font size at the program level.
I don't know.
At the project setting.
Sorry, too many people talking, and I can't.
¿Qué? Ah, así. Pero es que yo no soy usuario de Mac, nena. Yo no soy usuario de Mac. Estás ahí muy sentado y puedes venir.
Yo con un zoom. Ah, no lo tiene. No lo tiene activado. No lo tiene activado, joder.
¿Me tira a mí los leones?
¿Qué? Try this. Se lo iba a activar.
¿Cómo se llama? Intrusion. I use Windows normally.
No, es en la pantalla.
A mí me parece súper lindo. Pero no sé, yo penso que se podría cambiar eso, de PyCharm.
Lo tienes desactivado.
Probably for good reason, but yeah, let's try. Maybe this.
Si quieres, sí.
Okay, good. Okay. All right, success. We can. Okay, let's try to parse this sentence. Okay, so here's my parser result, and for example, it's very convenient to have some information about how the sentence was tokenized, so I have lots and lots of information here in a particular format, but that's fine, which includes things like the starting and the ending position of the token, and what kind of part of speech was assigned to the token by the parser, and what the probability of that part of speech is, and so on. Furthermore, we have how many results? We have 38 different interpretations of this sentence. Most of them are going to be extremely bizarre. You'd have to construct some kind of really weird universe in which Python is, I don't know, an object of a particular kind, which has properties such that it allows this interpretation, and so on. But the first couple are going to be the ones that we saw initially, the more likely ones. And so with these derivations, which are of course not visualized here in any nice way, represent our set of ideas about how syntax works in the English language. And it's not a perfect set of ideas, but it is a set of ideas which we can test. And so if we modify that set of hypotheses, we can then rerun the grammar on all the data that we used before for testing and see what changed. And we can compare the two versions of the structures, and we can conclude which one is better, for example. And this library makes it a lot easier compared to what we had before. Now, this thing is the semantic structure that corresponds to this sentence, which was built directly using the syntax. And I'm not gonna spend much time on this because what I'm interested more is the dependency structure anyway, which is a reduced version of the previous one, like a simpler version. And this guy, if I throw some other modules on it, can be visualized as that somewhat prettier graph, and then it can be put somewhere on paper. But this contains in principle all the information about all the nodes in the, I keep forgetting, all the nodes in the graph. Negation, and it's hard to show. Yeah, okay, negation, the studying event, the condition, not the conditional, the because event, that something was named in a certain way, Python or whatever. All right, now I told you that, and you can see now that these results are quite complex, and in the end, when we have 38 different parses, and each parse has an ID, for example, and then you have 1,000 sentences, for example, or 100,000 sentences, and each of them has a number, and you want to know, sentence number 50,048, how many parses did it have, and what did I notice about any of those parses. In the end, you store that as a relational database. And here I'm going to load one of the existing ones. So forget now about Arthur not studying Python. We're not using that example anymore. So this is just a database that I already have on my computer. And let me just show you what it has. All right. Or try anyway. It has a database schema. But this is not what I'm. I'm not sure what is it that it's zooming.
Yeah, it looks like it's being truncated in some way.
Yeah. Anyway, not very easy to look at, I'm sorry, but there is a schema to this database, and you can study that schema and then use it to do whatever you need. How about I just... well, we don't have a nice large font downstairs, but we do have the representation of the variable here, so we can look. So right now, actually, let me just change this. So this sentence used to be, it snowed. Suppose I'm experimenting with something. I want to change it right here in the memory, and I can do so. There's like a number of things that I can call from this module of the PyDelphin library, and now it's going to be it rained rather than it snowed, and these changes can be saved, etc., etc. The entire database can be parsed in the batch mode, so it's going to take a second. So this would be the situation where I made some changes to the grammar. I want to reparse the entire test data that I had. So I can do so, and then I can inspect the, let's see what we get. Now this is impossible to look at. But we have a, we have a list of results, and each of the results has lots of information in it, including those interesting semantic graphs that we talked about. And finally, and that's about the last thing that I want to show you, because there isn't really, I couldn't really come up with like a specific set of things that would be more or less important. The library has lots and lots of things. Because it's a database, you can execute normal SQL queries over the database, and you can pick. See, in the console the font is bigger, but not in the debugger. Okay, I suppose that's fair. All right, so we parsed 107 sentences in that database, and then we executed this SQL query, which basically says, give me all the sentences which are greater, that in length are greater than 5, and which were in fact admitted by the grammar, considered possible by the grammar. And it turns out there is only one such sentence, and it happens to be this. All right, this is basically what I wanted to show you. And now you can ask me any questions about either this or those interesting large language models that you all want to know about.
We have a question there.
Yes.
Hi, Olga. First of all, thank you so much. This is so interesting. I don't know anything about text processing, so it's a really good insight about this topic. And I was wondering two things, mainly. So the first one is, you said, like, for instance, in this first example, we have like 38 different results, and there's a probability attached to each one of them. It kind of ranks them, right?
Yeah.
How does it compute the probability?
With statistical methods, for sure. Yeah. So in order to compute to know the probability, you absolutely do need statistical methods. So that part where I was talking about how we use formal methodology, that was to build the grammar. To build the grammar, we use formal methodologies. To rank parsers, for sure, we want to train a statistical model, which based on a lot of text, which will tell us what is more likely.
Right. Okay. So it compares it like the structures against the corpus, and it has. Okay.
Yeah.
Right. Thank you. And the other question was, I'm a bit curious about the database format. Like, what I don't know, is maybe Sparkule used in any of these, like the Wikimedia format, like this ternary databases that they use? Are these compatible?
Oh, I mean, I don't know what the differences, what specific differences might be. This is just a relational database. There's nothing to it. It's just a set of files where things have IDs and things are linked through that ID. So across multiple files, you will have data that is linked through that ID. There's nothing more to it. The way it appears in the debugger is non-sequential.
I guess that's it for me.
Thank you
so much.
Yes.
I got two questions too. The first is why linguists dislike so much graphical visualizations? Is that so they can say, I work in the real world matrix?
No, it's because we don't have time. No, we would love to have fantastic software which is written as software should be written and not the way we write it. We would love to have fantastic visualizations. We don't have time. Because
it's open source, no? It's open source. We can
yes,
contribute.
of course. Yes, of course.
Contribute.
You're welcome. You're more than welcome to contribute whatever fantastic visualization.
And the second question is more like, I have a problem and maybe some insight can help me. I work in a software for newsrooms, and part of it is I have created some kind of spell checking and grammar checking, like pieces of software put together, but it still gives a lot of false support. So
false positive. False positive, you mean something is considered ungrammatical where it in fact is grammatical?
Correct.
Or the other way?
A lot of misspellings and things similar, like real world language that is not like in the grammar or something similar, or a lot of new words that appear that are not in the Real Academia and things. So I have been trying ways to improve. There are two ways that I have thought. That is, one is statistics. If an error occurs a lot, so I must consider it valid and not showing. Another one is through BERT models, especially Ruperta, that is the Spanish one. So it can somehow tell me, well, this word looks like it's right because my model thinks that it is probable that word appears here. It's like what is being done in that area to like improve the models through real world usage.
The tension here is, as usual, as always, the tension is between precision and recall. So you can tweak your system. You can use something like a large language model, for example. But large language models are pretty impressive, all right? I'm not denying that. You can fine-tune them for lots of different tasks, including something like that. They can be prompted in pretty nice ways to tell you whether something is an appropriate sentence in a given context or not, and I'm assuming they're going to be pretty good, so that's what I would do. Assuming I have the resources, I would try some kind of prompting model.
Well, I've been trying without prompting, using like, because originally it was not created like a chat, it was created as a probabilistic model, so I've been trying to use like as purely as a probabilistic model without any kind of prompt. Just give me the probability that word appears here.
Yeah, well, I mean, what can I say? If you want a probabilistic model, you will just, your best bet is training it on more and more data until it starts behaving the way you want. This type of grammars will give you higher precision in the sense that they will not admit more things, which is not what you want. It sounds like you have the opposite problem. You want to admit more, you don't want to admit less. So yeah, so this type of technology is for situations where you have the other problem, where you are admitting too much.
Maybe the future is that somehow it suggests missing grammar rules. You have your grammar, you think covers all theoretical knowledge of the Spanish language, for example, but the system can detect somehow there is a missing rule here, because I have seen a lot of times that rule, and you can add it.
Okay, yeah, maybe.
But
Yeah.
is something done in that area, or do you know about? Or?
It's hard for me to map it exactly. If you want, we can talk about it later. You can explain to me better what is it that you mean by this, because I'm not sure I fully understand.
Okay.
But I'm pretty sure something is being done in that area, yes, because a lot of things are being done in computational linguistics today. Yeah.
Well, anything else? Someone else?
I'd like to make a question.
Yeah.
I noticed before when you made the imports that
Yeah.
you were importing T-SQL.
Yeah.
And I got curious about, of course, analyzing language. You have verbs, you have temporal relations. How do you solve these temporal relations in the language? Is somehow embedded in that database, or do you have structures?
By temporal relations? What do you mean?
Verbs in past tense, in future tense, and all these relations. I assume you in the database this is
the database is simply to store the results. It's not for the analysis. The database does not participate in any work. It is simply to store. The whole work is done by the grammar and the parser. There's only two things that do the work.
The temporal analysis goes in there.
In the grammar, not in the parser. The parser is just a parser. The parser it's a chart parser. It's an algorithm that tries to map the string to the structure that is possible in the grammar. The grammar is the part that will have some set of ideas about how temporal semantics is assigned to the verb based on how the verb was analyzed. So if it happens to be in the past tense, it will make sure to say that it is in fact in the past tense. Yeah. Any other?
You talked about four main languages, the
Mm-hmm.
Is there any tool that you provide that would allow me to create a different code that would be the name for, I don't know, Malaysian, Klingon, or any other language?
So yes, there is. It's not going to be easy and it's not going to be fast, but there is such a framework, which I apologize for forgetting the internet. I cannot show you the web page, but I can show you later. There is a framework which is called the grammar matrix, which belongs to the same family of technologies. And what you do there is there's the web interface where you specify the features, the typological features of your language, for which you have to know quite a bit. So that's your set of ideas about how the language is, but it's not like but at that point it's not code. So the grammar at the end is just some machine readable code. That web page allows you to do it in a more user-friendly way, so it will ask you questions like, what tends to be the order of the subject and the object, and that sort of thing, and then it will translate that into code. And so that makes it somewhat faster and easier to write a new grammar for a language for which a grammar doesn't yet exist. But it's still a pretty serious undertaking, especially if you wanted to have high coverage, which is what the previous question was about. Like, how do I do it that I admit enough strings and don't reject the ones that actually are good? Roberto, go. Finish, Roberto.
Languages in the same sentence, for example, do you have any issue with that?
Yeah, so that depends on the mode in which you run the grammar. If you run it in like a classic mode, it will reject the sentence because it will say, I don't know what these words are. But of course, you know, there are, you know, if the grammar relies on the lexicon, you're going to run out of the lexicon. Again, in the real world, you encounter right and left constructions and especially words which are not in the dictionary, so to speak, and that's completely normal. So you can run the grammars in a somewhat relaxed mode, and what is going to happen is the grammar is going to say that is some kind of word which I don't know what it is, but I'm going to treat it as a verb, for example, and that will be based on a statistical procedure that has to be applied first. So in the end, we do, of course, have a hybrid of that. There was one more question, I think.
Yeah, a very short one. Out of curiosity, like, how old is this project, more or less?
I think they started. I joined it about 10 years ago, but they started maybe 20 years ago. I think so. Yeah.
So I'm sure there's something about Galician there. Maybe a bit, right?
There is no Galician grammar in this framework yet. If the European Commission gives me money, I will build one.
So it will be a great mission for us to create that grammar.
If somebody's interested, let me know. By all means. The consortium is very welcome.
Another question is, how much is this the models, the grammars, compared with another tools like language tool or similar?
Language tool, I don't know what that is. It's a name, language tool.
It's a library and I think command line tool that contains grammar check with support to many languages. I don't know if does exactly the same thing. Language tool is very used to practical purposes.
I'll take a look. I'm not familiar with language tool.
Okay. Yes.
we are having another
Excellent.
now